Hey there! We're in lesson 9. We're going to continue with lesson 9, only specifically today we're going to talk a little bit about negative slopes. Okay? So we have two goals for today. The one is to find slopes of a graph or a table that are negative, something that we've done before, except we haven't really worked on negatives too much. And then the second goal is to write equations in the form y equals mx plus b. So building off of what we've been doing as of late. So with that being said, something that we have been talking about a lot and seeing is different types of slope. Specifically, we've been working with a lot of positive slopes. Positive slopes, again, you're going left to right. The m is positive. You're going up from left to right. So like this guy right here, he's going up from left to right. That is a positive slope. If you have a line on a graph that's going down, it's still linear, it's just going downward from left to right, that's a negative slope. And that's what we're going to focus on today. There are two other types of slopes that we've talked about. The one is just straight across, where you're not really going up or down. That's a zero slope. And the one that we've talked about that's weird when you do it in a calculator is undefined. It's where you get a zero on the bottom, and that's going straight up and down. Let's specifically talk about those negative slopes today. So here's a problem at the top of your notes. It gives you the situation. I'd like you to first pause and read it through on your own quietly. All right. So the problem says Elena is training for a bike race. She makes this graph to show the relationship between the time and distance if she maintains the same speed. Write an equation for this function. Identify the slope and the y-intercept and explain what each means in the context of the problem. So if you look at the graph itself, I want you to try to find the slope. Again, slope is m. I want you to try to find the y-intercept, that is b. So once again, if you don't remember, slope is m, y-intercept is b. All right, so looking at a graph, the y-intercept should always be very easy because you can see where it crosses the y-axis. So at 20, or the point 0, 20, that is our y-intercept, that's b. Now, the slope on a graph, you might remember, is rise over run. That's on a graph. So on the graph, if you do rise over run, the one thing you're doing, again, going left to right, when you pick 2 points, let's go from this point to this point. The rise, if I do that first, is a going downward rise. You go down, and that's actually a negative 5, if you look at the numbers. And then when you go over, your run goes from 20 to 40, so that's actually a positive 20. So your rise over run in this case is negative 5 over 20. Seems weird, but hey, that's a fraction. It's a slope. One thing we can do with this is we can reduce it. So I can divide 5 out of both the top and the bottom. And what I get out of that is negative 5 divided by 5 is negative 1. 20 divided by 5 is 4. So my slope then is negative 1/4. Okay, I want you to think about what that means in the problem though. The rise was the distance and the run was the time. That means if she keeps her speed, and she should end at 80 minutes, it looks like, for every 1 mile she goes, it's taken 4 minutes. So 1 mile off of her taken off of her to the finish, it's 4 minutes. Okay. Now, there's different ways that you could go about doing this. One other way I'd like you to look at is at a table. So you could always create a table for values, or sometimes you're given a table of values. If you look at the table of values, we still want to be able to find the slope and the y-intercept, even if it's negative. So again, the slope and the y-intercept. So the slope is our m, the y-intercept is our b again. Now you might recall the y-intercept on a table is just wherever that x is 0. So the y-intercept is where that x is 0, so the y-intercept is 20. And that's the same thing we got on the graph, it was 20. Now um, to find the slope on a table, you might recall the slope on a table is change in y over change in x. So to find the change in y, we have to look at the y values. So I'm looking at the y's here. And I gotta do my little loop-de-loops from one y to the next every time it's going down 5. So that's my constant change, while my x's, my change in x, is going up by 20 each time. Consistently. So my change in y over change in x in this case equals negative 5 over 20. And when you reduce that, you can divide by 5 on both the top and the bottom again, you get negative 1 over 4. Same slope that we had from the graph. So, last thing we'd like to do on this page is use this information to write an equation. Okay, and we're going to use that form y equals mx plus b like we've been using. So let's substitute for the m and the b, the slope and the y-intercept. We said that the slope is negative 1/4, and the y-intercept is 20. So if we put those in where they belong, we would have y equals negative 1/4 x plus 20. In other words, you start with 20 miles, and that's your starting initial value, and every 1 mile it takes 4 minutes. What I'd like you to do to finish this up is turn the page over, and there's 5 questions about the problem itself. Some of them are fill in the blank, but I'd like you to use the slope, use the y-intercept, and use the information from this problem to answer the questions. And that all goes back to our goals for today, which revolve around finding slopes of a graph that are negative and writing equations in y equals mx plus b form, specifically with negative slopes. All right, that's all. See you next time.